example of that.
Please. Yes.
I pointed out that his test for whether a gene was causal or not was to measure its association with whatever it is thought to be the cause of. So if you think you've got a gene which produces cancer, you ask how strongly associated is that gene with cancer? And I said, well, look, the problem with that, Richard, is that you're using a word cause in a different sense because you're talking or giving the impression that it's an active cause in the sense that molecules bumping into each other actively interact with each other. There are many other forms of cause. DNA is not an active cause, was my point. And the reason is that it isn't like proteins. Proteins are active causes. They actually do things. They are enzymes. They make reactions occur that would otherwise not occur. DNA does none of that. It's simply a form. It is a pattern, if you like, which gets used by the protein-making machinery of the body to create a protein. It doesn't actually itself actively do that. It's the ribosome in the cell, together with all the various processes there that enable proteins to be made, that interprets that form. Now, many years ago, over 2,000 years ago, one of the earliest Greek philosophers, Aristotle, made this point. There are fundamental differences between causation by shape, causation by form, causation by physical interaction, and causation by final cause. Those are at least 4 forms of causation. They're all fundamentally different. Now, I don't know why, but he didn't seem to see that, where he just simply said, well, but Dennis, they are active causes. But
Hmm.
I had already made the point that a form is not a cause in the same sense that molecules bumping into each other. There are different forms of causation. We come back now, of course, to boundary conditions and differential equations.